this lecture, we will be able to study about the FM receiver, and along with that, we will also study one type of AM receiver, which is single sideband receiver. Now, before starting the concept of the receiver, I would like to explain one concept of amplitude limiter, which is related with the frequency modulation. We have talked about amplitude limiter somewhere during the demodulators, and we said that the ratio detector is the one circuit which is going to provide the amplitude limiting by connecting a large value capacitor at the output, but none of the other type of demodulator, that is Foster-Seeley discriminator, single slope, balanced slope detectors, are not able to provide amplitude limiting. Now here we should discuss that why amplitude limiting in FM becomes important, and in the receiver also this particular block is always present. So you can see that this is nothing but the input waveform given to amplitude limiter. Means you can consider these are the waveforms which are nothing but frequency modulated wave. So this is the captured signal by the frequency modulated receiver antenna, and you can see the frequency of the signal is varying, but somewhere because of the multipath propagation, because of the noise present in the environment, you will see that somewhere the amplitude of the signal is also increasing. But what is desired in case of FM? In FM, the amplitude of the signal should not change, only the frequency will change, and because of that in FM, amplitude limiter block becomes very important. We have never talked about amplitude limiter during AM because AM the information is contained only in the amplitude, and because of that the AM circuitries does not require amplitude limiter, but in case of FM, amplitude remains constant, and because of the noise, if the amplitude changes, then amplitude limiter is required. So this is the AM noise which is present because of any noise signal. So this is the captured signal by the antenna. So amplitude limiter will have some threshold level on both the side, positive and negative side. So whatever noise which is captured by the antenna, that will be limited or that will be removed by the amplitude limiter, and the output waveform of amplitude limiter will look like this. So you can see on both the side, above and below, the threshold is receiver is going to capture by signal by removing the AM noise. So AM noise will be removed, and this is what is the function of amplitude limiter. So amplitude limiter will be present in the FM receiver, and that is why before starting with FM receiver, this particular concept is important to understand. So anything above the threshold will be clipped by the amplitude limiter, and therefore the noise signal will not be affecting our frequency modulated wave. Now comes the block diagram of the FM receiver, and this FM receiver works on the principle of super heterodyne radio receiver. So we had one lecture discussion that what is super heterodyne radio receiver, wherein you will be down converting the incoming RF signal, you will be down converting incoming RF signal into a new frequency which we call it as intermediate frequency. So heterodyning means mixing of two frequencies and they are high frequency, and that is why the word is super heterodyne. So the same block diagram of super heterodyne, same working principle will also be applicable for FM receiver. So you can see the diagram starts with the receiving antenna. Followed by that, there is a preselector. Preselectors are used to remove any image frequency which is present in the signal, and apart from that, it will give selectivity to the receiver. After preselector, there is a RF amplifier which will be utilized for giving the sensitivity, providing the proper gain, and providing the proper selectivity to the selected channel. After that, we have a mixer, which is the first mixer. input to the second one input to the mixer is the received RF signal. Second input will be from the local oscillator. So local oscillator and RF will convert into the new frequency, which we call it as intermediate frequency. Intermediate frequency will be the local oscillator frequency minus the incoming frequency, and that is passed through a band pass filter. For proper filtering of the signal, we get first intermediate frequency. After that, it is given to a second mixer and a second local oscillator pair. Output to that will be a second intermediate frequency. So we require a RF and IF amplifier. Why double conversion is done? Because with the help of double conversion, the frequency is down converted by two stages, and therefore the circuit can become simple if we have double conversion method. So there is a IF amplifier, and then after IF amplifier we have a band pass filter. So after every block in the block diagram, after each and every mixer, IF amplifier, RF amplifier, you have a band pass filter. Now the output of the band pass filter will be going to amplitude limiter, which we have just now discussed. Followed by that we have a demodulator. So whichever FM demodulators like Foster-Seeley discriminator, ratio detector, single slope detector, balance slope detector, any type of FM demodulators can be used, but ratio detector will be most useful because it provides amplitude limiting application. Followed by that, if you remember that the transmitter side we have used pre-emphasis network, which is going to artificially boost the high frequency signal. So to compensate for that particular effect at the receiver, we are using de-emphasis network. So application use of the de-emphasis network is explained in the separate video, and there I had explained that pre-emphasis is done at the transmitter to overcome the effect of FM noise triangle, and to compensate the effect of pre-emphasis we are using de-emphasis network at the receiver. So at FM you are having de-emphasis network, followed by that you are having audio amplifier, which is acting as a driver to a speaker, and then the signal will be audible onto the speaker. Now here the limiter stage is going to provide the AGC voltage to, now you can see here the limiter stage is providing AGC voltage to IF and RF amplifier. We have discussed AGC in the separate video, that AGC is used to compensate for a weak signal and to adjust the gain of RF and IF amplifier when the signals are received. So AGC is going to automatically decrease the gain when strong signal is received, and AGC will increase the gain when the weak signal is received. So this particular AGC voltage is generated from limiter. It can be generated through demodulator, which we have seen in AM. So AM, the AGC voltage will be generated through demodulator. So this is about the FM receiver, which follows the principle of super heterodyning, means down converting incoming RF to intermediate frequency with the help of local oscillator and mixer. The same principle is used for super heterodyne radio receiver also. Now another type of receiver which we are looking is the amplitude modulating receiver, which is nothing but our SSB receiver. So SSB receiver, we are going to see two types. One is coherent, another is non-coherent. As we have discussed, that non-coherent are the one which do not require any carrier recovery circuit at the receiver. Non-coherent receivers are the one which do not require any carrier recovery circuits at the receiver, and because of that, the non-coherent receivers are block diagram of the non-coherent receiver will be like this. So non-coherent receiver also works on the principle of super heterodyning, and remember that whenever we use the word of super heterodyning, you should have a mixer and local oscillator pair in the receiver. So you are having again a receiving antenna which will receive RF input signal. Followed by that, in this diagram, RF amplifier and preselector is combined in the same block. In the previous diagram, it was shown different. So RF amplifier and preselector is combined in the one block. Output is given to a mixer. Another input to a mixer will be local oscillator. We have we had detailed discussion of how mixer works in the video of super heterodyne radio receiver. So if you want to see the working of mixer, just go and refer the block of the video of super heterodyne radio receiver. There with the example, the working of mixer is explained. So output of the mixer will be nothing but intermediate frequency, and that intermediate frequency is given to IF amplifier, band pass filter. Followed by that, you will be having another IF mixer. Now, why this another mixer is there? Because whatever signal which we are receiving is our single sideband suppressed carrier signal. Intermediate signal is also single sideband suppressed carrier signal, but we know that we have to insert some amount of carrier which is nothing but reduced carrier. That is nothing but SSB RC. If you remember the generation of SSB signal using filter method, there we have talked about reduced carrier. So this BFO is nothing but bit frequency oscillator, which will insert some amount of carrier in the final output, and there you will be having your final demodulated signal. So this BFO is nothing but a carrier which is inserted to the output, and you will be having final demodulated output. So this is non-coherent SSB BFO receiver, which is working on the principle of super heterodyne radio receiver. Another type of receiver is the coherent SSB BFO receiver. So coherent, how it is different from the non-coherent? So if you see the block diagram of coherent receiver, it has a carrier recovery circuit present in the receiver, and this carrier recovery circuit will ensure that frequency and phase of the carrier is similar to that of the transmitted signal. So you have a receiving antenna, followed by that RF amplifier and preselector. The functions of RF amplifier, preselector, mixer, IF amplifier, band pass filter, all are discussed in detail in the video of super heterodyne radio receiver. So that particular video is very important to understand all the types of receiver, because blocks are more or less same in all the types of receiver. So coherent receiver are getting a carrier recovery from the received signal. There is a separate carrier recovery circuit which is generating a local oscillator, as well as it will generating a BFO. Now here there is no need of BFO because we are generating a carrier recovery at the receiver, and the same is given to IF mixer to produce the demodulation output. So we have SSB RC signal, and that SSB RC is nothing but single sideband reduced carrier signal, and that reduced carrier signal we are utilizing for the carrier recovery. So here you can see between coherent and non-coherent what is the difference. In the coherent we receive SSB RC, in the non-coherent we receive SSB SC. SSB SC means single sideband suppressed carrier. SSB RC means single sideband reduced carrier. Coherent means carrier recovery and frequency synthesizer is required. Non-coherent means there is no carrier receiver required at the receiver. Another important point which we have talked during super heterodyning, that local oscillator has to adjust its frequency as per the incoming signal frequency, and that is why capacitor of a preselector and local oscillator, they are gang tuned together. This concept is also explained earlier. So gang tuning will be done. Gang tuning means as per the received frequency, local oscillator will change its frequency so as to maintain constant intermediate frequency at the output. This is very important. Why local oscillator will change? Because constant intermediate frequency is required at the output, and this is what is called as gang tuning. So here we have studied the FM receiver, then SSB receiver, coherent and non-coherent, and all the types of receivers are working on the principle of super heterodyning, meaning converting the incoming RF signal into the intermediate frequency and then detecting the signal.